Hey friends, in this video we will discuss the nuclear chemistry. It is actually nuclear chemistry part 2. So we will start nuclear chemistry and we will understand the nuclear properties and other things. Okay, so let's start nuclear chemistry. Okay, this is the nuclear energy. Nuclear energy is equal to mc square. We know that Einstein, according to Einstein equation, energy is equal to mass into velocity of light का square है. So we know that what is the mass 1.66 into 10 raised to the power minus 27 kilogram. So we will put the value here and we will also put the value of velocity of light, that is 3 into 10 raised to the power 8 meter per second. Okay, so we will put the value here and we will calculate. So first it will come in joule, then we will convert it into electron volt or mega electron volt. So at the end we will have 931.48 mega electron volt energy. It is the nucleus energy. Okay, so 931.48 mega electron volt energy you have to remember, because this value will be used for or it is used for very और सॉल्विंग न्यूक्लियर केमिस्ट्री क्वेश्चंस, जो क्वेश्चंस आते हैं उनको सॉल्व करने के लिए ये वैल्यू इंपॉर्टेंट है. सो वी हैव टू रिमेंबर दिस. नाउ लेट्स स्टार्ट न्यूक्लियर चार्ज. व्हाट इज न्यूक्लियर चार्ज? न्यूक्लियस के ऊपर क्या चार्ज होगा? वी नो दैट न्यूक्लियस इज मेड अप बाय प्रोटॉन प्लस neutron. Okay, and proton has positive charge, neutron has neutral charge, non-charge. Neutral means no charge. So overall nucleus का जो charge होगा, it will depend on the charge of proton. So proton is positively, that's why nucleus will have, suppose this is the nucleus, so nucleus will have positive charge. So nucleus has always positive charge. Nucleus is positively charged. So this is the nuclear charge. So if sometimes it is asked in examinations to make some confusion, so don't be confused. Okay, so nucleus has always positively charged. Okay, now nuclear size. How can we calculate the nuclear size? So we know that volume is always proportional to area. V means volume, A means area. So volume is always proportional to area. If we consider nucleus is spherical, अगर nucleus को अपन spherical कंसीडर करते हैं तो वी नो दैट स्पेयर का वॉल्यूम क्या होता है 4/3 पाई आर क्यूब. सो वी कैन से दैट 4/3 पाई आर क्यूब इज proportional to area. So and since 4/3 pi is constant, so we can write r cube is proportional to a. So a is proportional, so r will be proportional to a की power y 1/3. Okay, so now we have to remove this proportional constant, so we will put r naught. R is equal to r naught a की power 1/3. So r naught represents the proportionality constant. Okay, so, and r naught, the value of r naught lies between 1.2 to 1.6 Fermi. Okay, so and 1 Fermi is equal to 10 raised to the power minus 15 meter, और यही जो होती है it is nuclear size. So nuclear size is 10 raised to the power minus 15 meter, and it is known as Fermi. तो आपको ये भी याद रखना है कि फर्मी क्या है. सो फर्मी इज 10 raised to the power minus 15 meter. So this is the nuclear size. Now come to the nuclear density. How can we calculate the nuclear density? अपने को बताएं nuclear density means density is always, density is represented by rho. Okay, so rho is a formula. If we see the formula of rho, so that is mass upon volume. Okay, mass upon volume, and we know that the nuclear mass is 1.66 into 10 to the power minus 27 किलोग्राम. और ए यहाँ क्यों लिखा है? क्योंकि नंबर ऑफ न्यूक्लियन समझ लो आप, है ना. and volume is always 4 by 3 pi r cube, and r को यहाँ पे represent किया है r naught से into a. What is a? Number of nucleons. So a cancels a. So 1.6 into 10 raised to the power minus 27 by 4 by 3 into 1.2 into 10 raised to the power minus 15 का whole power 3, because r naught की value I told you that value of r naught lies between 1.2 to 1.4 or 6. Okay, so we will consider 1.2 into 10 raised to the power minus 15 ka whole power 3. Okay, so if we will calculate it, the rho will come like 2.9397 into 10 raised to the power 17 kilogram per meter cube. So it is the nuclear density, and it is always constant, or it is always same for all the nucleus. सभी nucleus के लिए क्या generally same ही होती है. So you have to remember what is the nuclear density, that is 2.97 into 10 to the power 17. Okay, so with this way we can calculate the nuclear density. Now come to the nuclear spin or angular momentum. Okay, so angular momentum of nucleus is represented by vector j is equal to vector l plus vector s. What is l? We know that l is represented for angular quantum number. Okay, angular quantum number. Okay, and s is represented for spin quantum number. So overall j, angular momentum number, is represented by nuclear spin or angular quantum number momentum is represented by vector of L plus vector of S. Okay, and what is the j? J is under root j into j plus 1 h cut. So if and what is the h cut? H cut is h by 2 pi. This is the momentum. So under root formula comes now under root j into j plus 1 into h by 2 pi. And what is I? I is the, this is the angular momentum. So L, vector L plus vector S. For L की value आपको पता है, capital L value is always L1 2 plus L2 for so on. Okay, and what is the S? S is S1 plus S2 and so on. So at the end, nuclear spin value comes like under root I into I plus 1 or h cut. And what is the h cut? H cut is h by 2 pi. And what is h? H is Planck constant. So nuclear spin or angular momentum formula आ जाता है आपके पास I is equal to under root I into I plus 1 h cut. So this is the nuclear spin of angular momentum. Now come to the nuclear binding energy. This is a very important topic, or many times in examination it is asked, and questions based on this are also asked in examination. So what we have to discuss, or we have to understand what is nuclear binding energy. And for the understanding of this, first we have to understand what is mass defect, because mass defect plays a very important role to calculate nuclear binding energy. So what is the mass defect? Mass defect is the difference between the sum of the masses of individual nucleons that form an atomic nucleus and the mass of the nucleus. So yeah, it can be understood like theoretical mass minus practical mass. यूं समझ लो आप कि theoretical mass nucleus minus practical mass, that is mass defect. Okay, so mass में कितना change आता है when we calculate it and when we observe it. So what is the difference between mass? That is the mass defect. Okay, so basis on this we can make a formula like delta M is equal to ZMP plus NMN minus MA. This is the formula to calculate mass defect, where MP is mass of proton, capital MA is mass of a nucleus, Mn is mass of a neutron, Z is the number of proton, and N is the number of neutron. So all the values you have, so with this way or with this formula, you can calculate the mass defect. And we know that what is proton? It is a positive charge, और इसका charge कितना होता है 1.6 into 10 to the power minus 19 coulomb. And what is the mass of proton? Proton mass is 1.672 into 10 to the power 27 kilogram by, or या फिर we can say that it is 1.007276 unit or U. And we know the mass of neutron, or about neutron, that neutron are particle with no charge of nucleus, and इसके ऊपर कोई charge नहीं होता, that's why it is 0. And what is the mass of neutron? Neutron's mass is 1.67 into 10 to the power minus 27 kilogram, and it can be represented in U, what that is 1.008665. So these are theoretically actually, okay, these are theoretically. So with this way we can calculate the mass defect. Just we have to have two things: first, number of nucleons, and mass of nucleus, that should be given. So now how can we calculate the binding energy? First we have to understand what is binding energy. So what is binding energy? That is the energy required to separate a nucleus into its individual proton and neutrons. So nucleus के अंदर अपन we know that there are proton and neutron. If somehow if we are able to separate them, so for that separation, how much energy is required? That energy is binding energy. It is very similar to lattice energy. Similar means we can understand it with the example of lattice energies. The, that means if we think about lattice energy. So what is lattice energy? Lattice energy is the energy required to separate 1 mole of ions or 1 mole of ionic solid into its constituent ions, right? Or energy required to associate or to bind ions of 1 mole of ionic crystal. So similarly, binding energy is energy required to separate a nucleus into its individual proton and neutrons, or energy released when nucleus is formed from its individual nucleus. यानी कि प्रोटॉन और न्यूट्रॉन को सेपरेट करो, हाउ मच एनर्जी इज रिक्वायर्ड, एंड प्रोटॉन और न्यूट्रॉन को आपस में मिक्स करो, हाउ मच एनर्जी इज रिक्वायर्ड और रिलीज्ड. That is binding energy. And what is the formula of binding energy? E is equal to delta M C square. What is delta M? It is the mass defect. Okay, so E is binding energy, delta M is mass defect, and C is the speed of light, that is 3 into 10 to the power 8 meters per second. And the binding energy per nucleus we can also calculate with the formula like binding energy EB by nucleon numbers, how many proton neutrons are there. So formula बन जाता है delta MC square by A. So binding energy per nucleon is delta MC square by A. So with this formula, we can calculate the mass defect as well as binding energy of nucleus. Now, let's solve some questions so we can understand the binding energy. Okay, so nuclear binding energy, there are two methods to determine the value. Two methods means in 2 units we can calculate or we can represent the binding energy. First is EB unit, means EB means binding energy, that can be represented in joule, or EB that can be represented with mega electron volt. Okay, so in case of joule we have to take velocity of light like 3 into 10 to the power 8 meter per second, but in case of mega electron volt we have to use C square term like 931.5 mega electron volt by U. Okay, so for example, if we are having delta M is equal to 1 U, what is 1 U? 1U is 1.6 into 10 to the power minus 27 kilogram. This is the nuclear mass. Okay. So now we have to calculate the binding energy. So EB is equal to delta MC square. Delta M is given already, 1.6 into 10 to the power minus 27 kilogram into 3 into 10 to the power 8 meter per second whole power 2. So it would come in joule like 1.4904 into 10 to the power minus 10 joule. And if we want to convert it into, or if we want to calculate the nuclear binding energy in mega electron volts, so we have to use the value of C square like this. Okay. So 1U, U. So U cancels U and it comes 931.5 mega electron volt for a given mass. So 1 electron volt is 1.6 into 10 to the power minus 19 joule, that we have to remember. 1.6 into 10 to the power minus 19 joule किसके equal होता है 1 electron volt के equal. So these are two questions. You have to solve it, or if you would be able to solve it, it means you will be able to calculate the nuclear binding energy. Okay. So with this way we can calculate the nuclear binding energy. Now nuclear stability, that is given by magic numbers. What are the magic numbers? So nuclear stability means what? If nucleus is stable, then it nucleus is suppose stable, so it won't be radioactive. Okay. अगर न्यूक्लियस अगर स्टेबल है तो ये रेडियोएक्टिव नहीं होगा. क्यों? रेडियोएक्टिविटी कब होगा? रेडियोएक्टिव तब होगा जब न्यूक्लियस अनस्टेबल होगा and it want to stable, then it will emit the radiation. So न्यूक्लियस अगर स्टेबल है तो it won't be radioactive. So how can we say that nucleus is stable? So there are some magic numbers. Magic numbers means even number nuclei tends to be stable. अगर न्यूक्लियाई के अंदर जो न्यूक्लियंस है उसमें इवन नंबर है तो वो क्या होगा? स्टेबल होगा. द न्यूक्लियंस दैट आर मोस्ट स्टेबल आर 2 at 20, 28, 50, 82, 126, either proton or neutrons. If proton or neutron के number 2 at 20, 28, 50, 82, 126 है, then there is those nucleus are very stable. So these numbers are known as magic numbers. Why do we call them magic numbers? Because with the number of protons or neutrons like this, these, then their nucleus is very stable. That's why these are known as magic numbers. They have completed nuclear energy levels. Double magic, helium, lead इनके example. Okay, so this is the nuclear stability explained on the basis of magic number. So thank you for watching this video, and please like and subscribe this channel. Thank you very much for watching this video.